Good evening and welcome to the Q&A session 18 from the playlist of IIT-JEE Advanced Physics. The topic is the simple harmonic motion of a charged block in the presence of an electric field. So based on this topic, I have one question for this session. This question is very similar to what was asked in the IIT-JEE exam in the year 2011. So in the original question, or you can say the question which was asked in the IIT-JEE exam in the year 2011, there were four options given in the question, and we were supposed to find the correct option. But all the four options were related to finding the frequency of the simple harmonic motion and the mean position of the block. So here the question is, block performs a simple harmonic motion on a frictionless surface with a frequency of naught as shown in this figure. So this is a block which is resting on a frictionless surface. This is a rigid support to which this spring is attached, and one end of the spring is attached to this block. The block is carrying a charge Q. So this block is carrying a positive charge Q. Now if a uniform electric field is switched on as shown in this figure, so here an electric field is switched on and the direction of the electric field is given by this arrow. Then we have to find the frequency of the simple harmonic motion of this block and the new mean position of the block. Now here the natural length of the spring is to be taken as L. So the natural length of the spring is basically the length of the spring when the spring is not compressed or stretched. So in this question, the frequency of simple harmonic motion when the field is not switched on will be given by the formula, that is this F0 will be equal to 1 upon 2 pi, and this is the standard formula which I am using, divided by K by M. So this is the frequency of simple harmonic motion of this block when the electric field is not switched on. Now when the electric field is switched on, then the frequency of oscillation, that is the frequency of simple harmonic motion, will remain the same, because this frequency is not dependent on the external force. It is only dependent on K, which is the spring constant of this spring and mass of the block. Here M is the mass of the block and K is the spring constant of this spring. So the frequency of simple harmonic motion before the electric field is switched on and after the electric field is switched on will remain the same. That is, it will be equal to 1 by 2 pi under root K by M. Now let's come to the second part of this question, that is we have to find the mean position of the block when the electric field is switched on. When the electric field is not switched on, then the mean position of the block will be equal to the natural length of this spring. Here the natural length of the spring is equal to L. And when the field is not switched on, then this block is not being subjected to any external force. Now when the field is switched on, then what will happen? This block will be experiencing an electrostatic force, say F, and this will be equal to Q into E, and the direction of this electrostatic force will be along the direction of the electric field. That is, the direction of this electrostatic force will be as shown by this arrow, because the direction of the electrical field is also is in the direction as given by this arrow. So since this is a positive charge, so the direction of the electrostatic force will be along the direction of this along the direction of this electric field. So because of this electrostatic force, the spring will get compressed, and when the spring is compressed, then spring force or the restoring force will come into play, which will oppose this electrostatic force. Now the spring force, the numerical value of the spring force is equal to Kx, and at equilibrium this restoring force will be equal to the electrostatic force, and here X is what? it is the compression of the spring. So here the compression of the spring will be equal to QE by K. So at equilibrium, the electrostatic force will be equal to the restoring force, and the compression of the spring will be equal to QE by K. So the new mean position of the block, this will be equal to L minus QB by K. Here QE by K is what? It is the compression of the spring. So this block will move slightly towards this rigid support by the value equal to QE by K. So the new mean position of the block will be equal to L minus QE by K. So thank you very much for joining this session. In the next session, I will be coming up with a different type of a question which has been asked in the JEE advanced examination in the previous years. So, and the chapter will remain the same, that is electric charges and fields. So till then, have a nice day. Bye.